Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR GCSE Maths November 2018, paper 5, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another OCR GCSE Mathematics past paper walkthrough. Today we're going to be looking at November 2018, paper 5, which is the second higher tier paper, and it's non-calculator. Right, so let's get cracking. Question 1a. Work out the cube root of 64 times 2 to the negative 1. The cube root of 64, what times itself? 3 times is 64, that's 4, isn't it? So 4 times 4 times 4 is 64. I do recommend that you learn the first 10 cube numbers for your exams, so you can kind of just reel them off. All come in very handy for the non-calculator paper. And then a negative index means the reciprocal of, isn't it? So 2 to the power of negative 1 is just 1 over 2 to the power 1, which is just 1 over 2. So what we're being asked here is to work out 4 times a half. Half of 4 is 2. Simples. Okay, then part B. I've got 4.3 times 10 to the 5 plus 3.8 times 10 to the 4. Give your answer in standard form. Okay, so I've got two numbers in standard form that I'm going to add. Just take care because they have different exponents, don't they? This one here has got 10 to the power 5. This one's got 10 to the power 4. So they're not really alike, so we can't really just add them together. First step would be to get them to have the same exponent, and then we can add the mantissa parts together, the bit at the front. So I'm going to take that first part, 4.3 times 10 to the 5, and I'm going to break the 10 to the 5 up into two parts. I'm going to multiply it, well, kind of bring out a 10 out of it. So that's the same thing as 4.3 times 10 times 10 to the 4. So I've kind of just taken out one of the powers of 10 out of 10 to the power 5, and then what I can do is I can combine these two parts together. So 4.3 times 10 is 43. So I've got 43 times 10 to the 4 plus 3.8 times 10 to the 4. Now notice now that I've got 10 to the 4 here and 10 to the 4 here. So what I can do then is kind of factorize out 10 to the 4, and it will leave you with 43 plus 3.8 times 10 to the 4, like that. Okay, so factorising out 10 to the 4 out of both parts. You can see that I can then add the mantissa parts of these numbers in standard form together. So 43 plus 3.8, that's 46.8. So that's going to give me 46.8 times 10 to the 4. Okay, are we done? Not quite, because the answer does ask for us to give our answer in standard form, and whilst this has got a power of 10, the number at the beginning of the mantissa part is not a number between 1 and 10. So I'm going to do the reverse of what I did earlier. I'm going to divide out a power of 10 out of 46.8, rewrite it as, let's do it over here, as 4.68 times 10 times 10 to the 4. So I'm taking that power of 10 out of 46.8. And then what I can do is I can recombine it then with this power at the end. 10 times 10 to the 4 is 10 to the 5. So my answer is 4.68 times 10 to the, times 10 to the 5, isn't it? Question 2. By writing each number correct to one significant figure, find an estimate for this calculation. Now it's really important that you read these sentences above the calculation. Some people just see this and they'll start focusing on that straight away and they won't read the sentence that goes above it. You really need to make sure that you do. This one is giving you some very clear instructions. They're asking you to estimate. I've actually given you more information than they need. They don't normally tell you this bit. So we're going to write each number correct to one significant figure. Even if they told me to estimate it, that's what I would have done anyway. So a bit weird that they should tell you. But anyway, 606.3. What's that number correct to one significant figure? Well, the first significant figure is the first non-zero digit, which is that 6 there, isn't it? Which is in the hundreds column. So rounding 606.3 to the nearest 100 is going to be 600. Okay. And the second number, the first significant figure is the first non-zero digit. It's that one there. It's the 3. That's in the tenths column. So if I round off to one significant figure, I'm going to round off that number to the nearest tenth. So am I going to round up or down? Just look at the number next to it and to decide whether or not it is 5 or more or 4 or less. In this case, it's 4 or less. So I'm just going to round down to 0.3. Finally, 19.93. The first significant figure is that 1, which is in the tens column. So rounding 19.93 off to the nearest 10, that's going to be 20 then, isn't it? So my calculation becomes 600 times 0.3 divided by 20. Okay. So let's do the maths then. What's 600 times 0.3? That's the same thing as 60 times 3, isn't it? So that is 60, 120, 180, 180 over 20. Just cancelling those zeros out. 18 divided by 2. That's going to give me an answer of 9. Okay, so that's my estimate. Question 3. Jeff has 2 fair spinners. I've got spinner A. You can see it's got 3 numbers, 1, 7 and 9. And I've got spinner B, which has got 4 sections with numbers 2, 3, 4 and 5 written on them. Okay, so he spins both spinners and multiplies the number on each spinner. And I've got a sample space down here with the results. So I've got my numbers from spinner A along the top there, 1, 7 and 9, and my numbers from spinner B down the side. And in the middle, they've written down the numbers multiplied together. So this 2 times this 1 gives me 2 there, doesn't it? Okay, so I need to multiply the number at the top of the column and the left of the row together to get the number in the table. So this number down here then, I'm going to get by multiplying 9 and 4 together, aren't I? So 9 times 4 is 36. So that number there should be 36. Okay, and then to get the next number, this 9 times this 5 is going to give me this number in here, isn't it? So 9 5s are 45. Okay, so I'm just going to write 45 in there. Okay, so 36 and 45. Part B says, Jeff wants to work out the probability that the outcome of the multiplication is an even number or a prime number. Here is his working. The probability that the outcome is an even number is 6 out of 12. The probability that the outcome is a prime number is 3 out of 12. So the probability of the outcome being an even number or a prime number is 6 out of 12 plus 3 out of 12, which is equal to 9 out of 12. Jeff is wrong. Explain his error and give the correct answer. Okay, so coming back to our table of our sample space that we made back in part A. So what he's done is work out the probability that the answer is even. So I assume what he's done is counted how many even outcomes there are. So even be that one, that one, that one, that one, that one, and that one. So that's given him his 6 out of a total of 3, 6, 9, 12 outcomes. And then the probability then that it's prime. Okay, let's do these in green. So which answers are prime? 2's prime, 3's prime, 5's prime, 14 isn't, 21 isn't, 28 isn't, 35 isn't, 18 isn't, 27 isn't, 36 isn't, 45 isn't. Okay, so it's just those three numbers then in the first column, because obviously they're not going to be prime if they've got other factors. So probability that it's prime is 3 out of 12. So what he's done there then is said, well, the probability then of even or prime is the probabilities added together of those two things. So adding the 6 over 12 plus the 3 over 12 together. But where it's gone wrong is this one here, isn't it? Because 2 is an even number, so it is counted in that 6 over 12. But 2 is also a prime number, so it's also been counted in that 3 over 12. So it's actually been counted twice. So the probability that it's even or prime should be that 2, the 3, the 4, the 5, the 14, the 28, the 18, and the 36. How many is that? That's 1, 2, 3, 4, 5, 6, 7, 8. So it's not 9 out of 12. It should be 8 out of 12. And the reason he's got it wrong is he's double counted 2. Okay, so let's go back and write that down as our answer then. So Jeff has counted the outcome 2 twice, as it is both even and prime. And we said the probability of even or prime should be 8 out of 12 and not 9 out of 12. Okay. Question 4. A solid metal block has mass 500 grams and volume of 125 cubic centimeters. Work out the density of the block. Give the answer. Give the units of your answer. Okay. So a solid metal block has mass. So mass is equal to 500, and then volume is equal to 125, and we want to work out density, don't we? Okay, so I know a formula for density. It is density is equal to mass divided by volume. Comes up in physics as well, this one, doesn't it? So you should know this one. So density is mass, which we found out to be 500, divided by volume, which is 125. Okay, how many times does 125 go into 500? 125 doubled is 250 and doubled again is 500, so it goes in 4 times, doesn't it? So it's 4 somethings. What's the unit? Well, volume was in grams, and we've divided it by mass was in grams, and we divide it by volume, which is in cubic centimeters. Okay, so that's what we're going to write down as the units. Grams / divided by cubic centimeters. So it's 4 grams per cubic centimeter. That's how you would say it. Question 5. The depth of water in a garden pond is 57.8 centimeters. The depth decreases by 0.3 centimeters per day. Assume that the depth continues to decrease at the same rate. After how many days will the depth reach 54.2 centimeters? Okay, so it starts off at 57.8, and we want to know how many days it takes to reach 54.2 centimeters. So let's work out how far it's actually decreased. So total decrease, or the total drop in depth is equal to 57.8 minus 54.2. Now I like to write these little sentences at the start of any calculation I do. It makes it clear to both the examiner what I'm doing, and also to myself when I come back and check my work later. Okay, so it's just a good idea. Otherwise you just end up with a page full of numbers, and it's really difficult for the examiner to mark and for you to make sense of your own work in when you come back and check your work. So just get into the habit of writing these little sentences at the beginning, or part sentences, or a few words to describe what it is you're actually calculating each time. So what is 57.8 subtract 54.2? Well, that's going to be 3.6. 3.6. Okay, so the total drop in depth is 3.6 centimeters. Okay, and now we are decreasing by an amount of 0.3 centimeters per day. So that's a division then, aren't we? So to work out the number of days, it's going to be that 3.6 centimeters divided by the daily drop of 0.3. So how many times does 0.3 going into 3.6? Now, if you don't like decimals in your division, you could just times top and bottom by 10. That would just get rid of all the decimals straight away, wouldn't it? So it's a bit like fractions. As long as you do the same thing top and bottom, you don't change the fraction. So that would give me 36 over 3, which is a lot easier to do, isn't it? How many 3's go into 36? It goes in 12 times. Okay, so the number of days it takes is 12. 12 days is my answer. Part B says, if the depth of the water decreases at a slower rate, what effect will this have on your answer to part A? Okay, so coming back to our calculations from part A, it's not going to change anything to do with the drop in depth. That's still going to be 57.8 and 54.2. That's not going to change. So the total drop is going to stay at 3.6. What is going to decrease is this divisor down here. This is going to get smaller. So if you divide something by a smaller number, then the answer is going to be bigger, isn't it? So for instance, if I divided 36 by 2, which is a smaller number, I'm going to get 18, which is bigger than 12, the number I get when I divide it by 3. So making the divisor smaller will make that number there bigger. So that will increase the number of days then, won't it? Okay, so coming back to our question, what effect will this have on your answer to part A? So I'm going to write down the number of days will increase. Question 6. Sally has 30 feet of ribbon. She cuts strips each of length 2 and 2/5 of a feet from the ribbon. Sally says, I can cut 13 of these strips from the ribbon. Is she correct? Show how you decide. Okay, so I've got 30 feet of ribbon and I want to cut it up into strips of length 2 and 2/5. So that's a division, isn't it? I want to divide it up. So what I'm doing then is 30 divided by 2 and 2/5. What's that then? Okay, well, if you want to do division or any operation with fractions, not so easy to do it with mixed numbers. Let's convert that 2 and 2/5 first into a top-heavy or an improper fraction. So I'm just going to multiply 2 times 5 together. It gives me 10, and then add on the 2, so that's 12, isn't it? So 2 and 2/5 is 12/5. The 30 remains at 30, so I've got 30 divided by 12/5. Okay? Next thing, fraction division, dividing by a fraction. Now, some people can remember fraction division using this keep, change, flip. It's just a handy way of remembering what to do in what order. So maybe it works for you. Keep. So that means keep the first number. So the 30 stays being 30. Going to change the sign. So the divide becomes a times. And flip. We flip the last fraction over. So that becomes, rather than 12 over 5, we get 5 over 12. So what is 30 times 5 divided by 12? Okay, I'm going to see if I can do the division first. 12 into 30. That goes, well, 12, 24, and bust, isn't it? So it goes in 2 and a bit. 2 remainder 6. So it kind of goes in 2.5 times, isn't it? You've got 12, 12, and 6 fit into 30. So I'm going to write that down as 2.5 times 5. 2.5 times 5, 2.5 and another 2.5 is 5, so it's going to be 10, 12, isn't it? 12.5 altogether. So 12.5. Okay, so is she correct? Well, no, because I haven't made 13. I've made 12 and a kind of a stumpy one, haven't I? So Sally is wrong. She has only made 12.5 strips. Question 7. Emily spent £2,400 on holiday in 2017. This was 20% more than she spent on a holiday in 2016. Calculate the amount she spent on holiday in 2016. Okay, now I tend to do percentages using the this triangle, which is FOM, where F stands for final, O stands for original, M stands for multiplier. So it's a bit like a DST triangle, so if you've used one of those before, it's the same principle. So I try and think of final, original, multiplier, try and work out what those three values are, and therefore which one's missing and I want to find. Okay, so let's think this through. Emily spent £2,400 on a holiday in 2017. This was 20% more than she spent on a holiday in 2016. So this 20% more is a percentage increase, isn't it? So that is where I'm going to find my multiplier from 20% more. 20% more than what? Must be more than 100. So you start with 100, going to increase it by 20%. That's going to give me 120%, which as a multiplier is 1.2. And then, so we need to work out whether this 2,400 here, is that the final, or is that the original? So 2,400 was in 2017, and we're interested in what she got in 2016, which is earlier. So 2016 amount must be the original. So this 2,400 then is the final amount, isn't it? So the final is 2,400. The original is what I want to find, and the multiplier is 1.2. So this is what we call a reverse percentage question, then, isn't it? Okay, so if I want to find the original, we put our thumb on the O, and it tells me what to do with the other two things. So the original equals final divided by multiplier. Original equals final divided by multiplier. Okay, in this case, the final was 2,400. The multiplier is 1.2. So how many 1.2s go into 2,400? Again, if you don't really like doing division with decimals, if I multiply top and bottom by 10, just a little trick, kind of gets rid of that decimal on the bottom. So it's going to give me 24000 on the top, divided by 12. Maybe that goes a bit better for you. So 12s into 24 go twice. So 12s into 24,000 go 2,000 times. So 2,000. So calculate the amount she spent on holiday in 2016. It was £2,000. Okay, we're done. Question 8. The table shows the number of computers sold in Tom's shop each quarter from 2015 to 2017. So you can see that the first 8 quarters have been plotted. So that's all the 2015 values and all the 2016 values. Looks like his sales are a bit seasonal, aren't they? They go up and down. So the fourth quarter is the highest on both. It's probably like because it's Christmas or something like that. That's probably why it comes out to be the highest. Anyway, so we need to plot these numbers on the end then, don't we? This quarters 1, 2, 3, and 4 at these values. 27, 40, 30, and 58. Okay, so we just need to add those onto the diagram in exactly the same way as they have been for the other ones. So, the first quarter is 27. Now notice the number of computers at the side here are going up in 10, 0, 10, 20, 30, and we've got one division in between. So that division is going to be 5, isn't it? So it's going to go 0, 5, 10, 15, 20, 25. So 27 is going to be halfway between the 25 and the 30, slightly closer to the 27, isn't it? Okay, so that's where I'm going to plot it. Sort of halfway, slightly closer to the bottom line than the top line. Okay, I'm going to use the same style. So I'm going to do a little point like that. Next point, 2 goes to 40. That should be a nice easy one to plot. It's just on the lines. 2 goes to 40, goes there. 3 goes with 30, again should be a nice easy one to plot. 3 and 30 goes there, and finally 4 goes with 58. So that's going to be halfway between 55 and 60, maybe slightly closer to the 60 than to the 55. I'm going to put it there. Okay. So once I've got all of those points plotted, I'm just going to follow the same pattern as before. Going to join them with a dotted line. Okay, that would do. Good job. Part B says Tom adds the 3 results for quarter 1 and he adds the 3 results from quarter 4. Tom says the ratio of the total number of computers sold in quarter 1 compared to the quarter 4 is 2 to 5. Is he correct? Show your reasoning. Okay, well let's pull up the table we had from question, or from the first part, part A. Let's see if we can find all the quarter 1s and quarter 4s and compare them. So quarter 1 is going to be that 13, the 20 and the 27. So quarter 1 is going to be 13 plus 20 plus 27, and quarter 4, sorry, is going to be 45, 47 and 58. So 45 plus 47 plus 58. So 40 and 40 is 80, plus 5 and 7 is 92, plus 8 is 100, plus 50 is 150. So that adds up to 150. Q1 adds up to 47, 50, 60. So we've got 60 to 150 then, haven't we? Okay. So does the ratio 60 to 150 cancel down like they say? So this was quarter 1 and this was quarter 4, wasn't it? Okay, so well, I can see I can scratch off those 10 straight away. So 6 to 15. 6 and 15 are both divisible by 3. So 6 divided by 3 and 15 divided by 3 gives me 2 and 5. Oh yeah, well he was correct then. So he was correct. Part C says make 2 comments about Tom's sales over the period 2015 to 2017. Well, I've already kind of mentioned this a little bit. That most of his sales are in the 4th quarter, aren't they? So we can say Tom's sales are seasonal, with highest sales in the 4th quarter. That could be one observation. And the other one, I think you can see over time there is an upward trend, isn't there? So there is an upward trend indicating that sales are increasing over time. Okay, there is an upward trend indicating that sales are increasing over time. D. Tom predicts that he will sell more than 60 computers in the fourth quarter of 2018. What assumptions has he made? So Tom predicts that he will sell more than 60 computers in the fourth quarter of 2018. Okay, let's go back and look at the data. Well, you can see that he's definitely, as I mentioned earlier, he's got an upward trend, isn't he? So, you know, this point to this point to this point is going up. It's already at 58, and you can see from 45, it went from 45 to 47, and from 47 to 58. So there's a bigger jump from 2016 to 2017. But even if it's a small jump from 2015 to 16, an increase of 2, that's going to take him up to 60, isn't it? So what information is he using? He's using the increase over time to show that it's going to increase more then, isn't he? So I think we can just say that Tom assumes that the upward trend in sales will continue. Okay, so seems a reasonable assumption based on his data. Question 9, rearrange this formula to make y the subject. I've got x is equal to y squared plus 7. So I want to get y by itself. So I want to unwind this really, and the way you do it is in the kind of opposite order to BIDMAS. So if you were trying to work out y squared plus 7, BIDMAS would say do the indices first and then do the addition. So when you're rearranging, you're kind of going through BIDMAS backwards. You're going to go through and kind of unwind it. So here, the subtraction, which would normally, the addition and subtraction that normally comes last, is the first thing I'm going to move over. So rather than add in 7, I'm going to subtract 7 from both sides. That's going to give me x minus 7 is equal to y squared. And then I'm going to deal with that square sign. What's the opposite of squaring? It's square rooting, isn't it? So square root in both sides. So if I square root that side and I square root that side, square root of y squared is simply y, and I'm going to get x minus 7 all square rooted. Okay, so just spinning it around to put y at the front, y is equal to the square root of x minus 7. Question 10. Triangle A and triangle B are drawn on the coordinate grid. Yes, they are. Part A says, draw the image of triangle A after a rotation of 180 degrees about the point 0, 0. Okay, so one way of doing this, if you're not very good at rotations, would be to go and ask the invigilator for a sheet of tracing paper. Lay that over the top of your diagram. Next, what you want to do is to put a little cross where the center of rotation is. At this point here, it's at 0, 0, isn't it? So if you put a kind of a cross going through 0, 0, it will help you keep track of your rotations. Then you want to put your pen tip or your pencil tip at 0, 0 and turn the paper round. Okay, so when you get that little cross line up again for the first time, you'd have done a 90 degree turn, and then let it go around one more time so it lines up one more time, and you've got a 180 degree turn. Now, when you've got a 180 degree turn, they don't bother telling you if it's anti-clockwise or clockwise because you're going to land in the same place. In this case, I'm going to have the points as indicated here. So I'm just going to remove the tracing paper carefully and put the image points in. So my 3 image points are going to be here, here, and here then, aren't they? Okay, so just carefully put the image points on, and then once you've got the image points on, you can then join them up with a ruler. like so. So rotation, it should change the orientation and position of your shape, but not its overall shape. You can see it's still the same shape, it's just kind of upside down and move to a different quadrant. Okay, so that's my rotation. The next thing we need to do is to draw the image of a triangle after a transition of by the vector 2, -7. Well, a vector 2, -7, if you were going to draw that vector, it would be 2 along and 7 down. So I need to take each one of my points and move it 2 units to the right and 7 units down. So let's take this point here first of all. Go in 2 units to the right and 1, 2, 3, 4, 5, 6, 7 takes me to that point there. Okay, just going to rub that out again. So, okay, similarly, this point here is going to be translated to that point there, and this point here is going to be translated to that point there then, isn't it? Okay, once you've got your corners, then you can join them together with your ruler again. Part B says, describe fully the single transformation that maps triangle A onto triangle B. Now this is a 3-mark question, so you expect to give 3 bits of information in order to get to the mark. Let's go back and have a look at the diagram. You can see A and B, they're sitting next to each other. A is bigger than B. Remember, A is the original image object though, and B is the image. So A has been translated onto B. So I think this is going to be an enlargement. It's one of those crazy mathematical enlargements where your image ends up being smaller than the object. Okay, but we still call that in maths an enlargement, weirdly. But anyway, let's draw on some ray lines. Pick 2 points that go together. So this point here matches up with this point here on the image. So if I draw a ray line through those points, I'm going to use green. So like so. Just draw these faint really, and then I'm going to do the same. I'm going to find another 2 points that go together, so that tip of the triangle goes with that tip of the triangle down there, doesn't it? So I can put another ray line through those 2 points, and you should find that your ray lines converge on a particular point, and that particular point is known as the center of enlargement. In this case, it's this point here, isn't it? And that is the point -1, 2. Okay, so that's my center of enlargement. Now I need to give 3 bits of information. It's an enlargement is one thing. It has a center of enlargement at -1, 2. That's the second thing. And the third thing is going to be the scale factor. Now notice that this line here is 4 units and its matching side is 2, which is half as big. So that's telling me that the scale factor is a half. Okay, so they're the 3 things that I need to mention when I describe this transformation. It's an enlargement, 1 mark. Center, -1, 2. Scale factor, 1/2. Okay, they're my 3 bits of information for my 3 marks. Question 11. The price of a washing machine is reduced by 20% for a sale. Afterwards, the sale price is increased by 30%. Joachim says, the washing machine is now 10% more expensive than before the sale. Explain Joachim's error and work out the correct percentage change in the price of the washing machine from before the sale to after the sale. Now, Joachim's mistake here is he's treated these 20% and 30% as additions, isn't he, or addition subtractions, when really they're multipliers. When we reduce something by 20%, we're not going to be subtracting 20% and adding on the same amount plus another 10%. That's not how it works, because when you increase by 30%, you've got less there to start with. So I'm going to write down that his error is he has added, subtracted, and not used multipliers. Okay, and we're going to show that he's incorrect by doing the maths ourselves, aren't we? So let's assume, it's a bit difficult because we haven't got an amount, have we? So we're applying a percentage to, well, we haven't been given the amount of the washing machine. So we're going to assume an amount. So we're going to assume washing machine costs 100. Okay, and we'll work out what the percentage change to £100 would be, and then it will be the same no matter what the price is. Okay, it'll just give us something to work with then. So then we're going to do a reduction of 20% to start with, aren't we? So if we do 100, if we're going to reduce something by 20%, then that is 80% of what we had to start with. So I'm going to be multiplying it through by 0.8. That's going to give me 80. Okay, and then if I then want to increase by 30%, it would be 80 times by, and what's the multiplier? 100% plus 30% is 130%, so my multiplier is going to be 1.3. So 80 times 1.3. So one lot of 80 is 80, 0.3 lots of 80. So a tenth of 80 would be 8, and then 3 lots of 8, 8, 16, 24, isn't it? So that would be 104. Okay, so our washing machine would end up costing £104. It was £100, it's now £104. I make that an increase of 4%. Question 12. AOB is a sector of a circle, centre O and radius 6. The length of arc AB is 5 pi centimetres. Find the area of the sector. Give your answer in terms of pi. Okay, so we've been given a diagram here for our shape. We haven't, not all the information is on there, is there? We can see that the radius is 6, that's there. We can see AOB, but we've not got the arc length on there, so we need to add that to our diagram. That's 5 pi. So the distance around here, the arc length, is this kind of curved section here, isn't it? So round from there to there, that is 5 pi. Okay. Now, what we don't have at the moment is this angle here, theta. I think that's probably what we need to find first of all. So we need to find that angle. Once we know that angle, then we can work out what fraction of a circle we've got, and therefore we can work out what the area of that sector is. Okay, so we're going to start with the arc length formula and work backwards to find the angle, and then forward again to find the area. So arc length then is going to be theta over 360 times pi d, isn't it? Pi times diameter, which in other words is 2 pi r. So pi d or 2 pi r. So I'm going to use 2 pi r because we've got the radius here of 6. Okay, so I know the arc length, it's 5 pi. Don't know theta. Hopefully I'm going to find it. And I know that r is 6. Okay, so I've got 5 pi equals pi theta over 360 times 2 pi times 6. Right, I've got pi on both sides. Let's cancel those out. So on the left hand side I've got 5, and on the right hand side I've got theta over 360 times 12. So let's just tidy that up. So 2 times 6 is 12, 12 theta over 360. Okay, now we want to get theta on its own, don't we? We want to work out what the angle is. So let's cross multiply, times in both sides by 360. We'll move that 360 up there, and dividing both sides by 12. We'll move that 12 to the denominator on my other side. So I'm going to get 5 times 360 divided by 12 is equal to theta. I'm tempted to do the division first because that's going to leave me with an easy number to multiply. So how many times does 12 go into 360? Well, 12 goes into 36 3 times. So 12 must go into 360 30 times. So then theta then is going to be 5 lots of 30, which is going to be an angle of 150. So then theta equals 150 degrees. Okay, so now I know what theta is, I should be able to work out the area. So area of sector, so that is going to be theta. So my area is going to be theta over 360 times the area of a circle, which is just pi r squared, isn't it? Okay, so I now know that theta is 150. So I've got 150 3/60ths of pi times r squared. R, remember, is 6. So it's pi lots of 6 squared. So that is going to give me 36 times 150 pi over 360. Okay, I'm going to divide that 10 into that one, giving me 15, and 36, and then I'm going to divide the 36 into that 36. So that is going to leave me with 15 pi then, isn't it? So the area then is just going to be 15 pi. Question 13. In the diagram, ABC is a right-angled triangle. P is a point on AB. BC is 40 meters. AP is 20 meters. And angle ABC is 30 degrees. Okay, now I do suggest you read through this information above the diagrams carefully and just double check that everything written up there is on the diagram. In this case it is. I've got the BC is 40, I've got AP is 20, and I've got the angle and I've got the right angle marked. But it isn't always the case, and it's always worth just double checking, because otherwise you might be staring at a problem that you can't solve because you don't have all the information. Okay, but all the information is on the diagram here, so we can proceed. Show that AC is 20 meters. Where's AC? AC is this side here, isn't it? I need to find that line, AC. How can I do it? Well, if we look at triangle ABC, that's just a right angle triangle, and I know an angle, 30 degrees, and I know a side, a hypotenuse, so I can find a second side, no problem, just using trigonometry, can't I? Okay, so if 30 is the marked angle, then the 40 degrees, that's the hypotenuse, isn't it? And AC is the opposite, and AB is the adjacent. Okay, so time to think about our mnemonic, SOHCAHTOA. SOHCAHTOA. Now, we have got a hypotenuse, and we want the opposite. So which one is about O and H? It's the SOH part, isn't it? SOHCAHTOA. So that's the sine of an angle is equal to the opposite over the hypotenuse, if we're writing that out nice and long. Okay, so we're going to write out the correct trigonometric ratio. Next thing is to sub in what we know. We know the angle is 30, so let's put that in. So sine 30 is equal to the opposite. That's what I want to find. It's the side AC. And then hypotenuse we know is 40. So rearranging, multiplying both sides by 40, we'll cross multiply that 40 from where it is to the other side. So I'll get AC is 40 sine 30. Okay, at this point you'd reach for your calculator and then realize, oh, I don't have my calculator. This is the non-calculator paper. So am I stymied? Nope, because you should remember your exact trig values, shouldn't you, for angles 0, 30, 45, 60 and 90. If you didn't remember those, why not? You need to know them for your exam, don't you? Okay, there are various ways of remembering these values, but you should remember that the sine of 30 is a half. Okay, so I'm going to replace sine 30 from my knowledge bank of sines and cosines that I need to remember and sub it in. Okay, so 40 times a half is equal to AC, so that makes AC equal to 20 as required. Now in part B we're asked to find the length of PB. Now PB is, well, it's this bit down here, isn't it? Okay, which is part of the adjacent of the triangle ABC. Okay, so I think what we're going to have to do is we're going to use trigonometry in ABC again to find this distance AB and then subtract 20 from it to find PB. I think that's going to be the easiest way of doing it. Okay, so we're going to start off with wanting to find the adjacent. We know the hypotenuse. This time we're going to use cosine then, aren't we? Because cosine is equal to adjacent over hypotenuse. So let's start the same way. Cos of our angle is equal to the adjacent divided by the hypotenuse. Sub in what we know. Cos 30 is equal to the adjacent, which is the side AB, divided by the hypotenuse, which we know is 40. So that means that AB is going to be equal to 40 cos 30. Okay, so it's time to raid the memory bank again and try and remember what cos 30 is equal to. So again, if you recall your exact values that you need to remember, you should know that the cos of 30 is root 3 over 2. So subbing in root 3 over 2 for cos 30, root 3 over 2 times 40 is AB then. So half of 40 is 20, so AB is 20 root 3 then. So AB is 20 root 3. Okay, but we don't want AB, we want PB. So we know that PB is AB minus AP. We just found AB is 20 root 3, and from the diagram I can see that AP is 20. Okay, so I've got 20 root 3 minus 20. Now notice you've got 20 in both of those, so that means I can factorize 20 out of that, can't I, and rewrite that as 20 lots of root 3 minus 1, which lo and behold is the form that we were asked for. We were asked to write in the form a lots of root 3 minus b. So I've got a must be 20 and b must be 1. So then I've got 20 lots of root 3 minus 1. Good job. Question 14. The diagram shows the line y is equal to 2x plus 1 and 7x plus 4y is equal to 28. So I'm guessing that the y is equal to 2x plus 1 must be this one. Well, I'm not guessing, I kind of know it because it's going through 1 and has a gradient of 2. So by a process of elimination, that one there must be the other one. That must be 7x plus 4y is equal to 28. Now we're told that the region R satisfies these inequalities. Y is less than or equal to 2x plus 1 and 7x plus 4y is greater than or equal to 28 and y is greater than 1. By drawing a third straight line, find and label the region R that satisfies these inequalities. Now you notice that y is less than or equal to 2x plus y is strangely familiar. It looks very much like the y is equal to 2x plus 1 that we noted already on our diagram. And 7x plus 4y greater than or equal to 28 is spookily like 7x plus 4y is equal to 28, which you already noted on our diagram. So the only one that's missing then is this one here, y is greater than 1. So the related equation to that then is y is equal to 1. So if we plot that line, then we should have all the lines that we need. And the line y is equal to 1 is super easy to do, isn't it? It's just a horizontal line through y is equal to 1. So getting my big ruler out, drawing a line from y is equal to 1. That would be that line there, won't it? Now this is y is greater than 1. Now notice that the other ones were greater than or equal to or less than or equal to. So they've been drawn with a solid line. Now we want strictly greater than, so we need to draw our line as a broken line, a dotted line. Like that, because the points on this line are not actually part of the region. They have to be slightly bigger than 1 in order to be part of the region. Okay, so we draw that one with a broken line or a dashed line like that. Okay, so now we've got all the lines that we need for our diagram. So y is going to be less than or equal to 2x plus 1. So it's going to be, so I'm assuming it's going to be this region in the middle of the 3 lines like that. I'm assuming it's going to be here, but I feel like we should test this somehow. Okay, and a good way of testing it is to pick a point that lies somewhere in the range where you think it's going to be. So I'm going to pick the point 2, 2, because that's smack bang in the middle there. And I'm just going to test it in each of these inequalities just to make sure I'm on the right side of each of my lines. So is y less than or equal to 2x plus 1 when at the point 2, 2? So y then, 2, is that less than or equal to 2 lots of 2 plus 1? Is 2 less than or equal to 6, in other words? Well, that is true. So, okay, we're on the right side of the yellow line. Let's just double check the green line. So for 7x plus 4y greater than or equal to 28, 7 lots of 2 plus 4 lots of 2, is that greater than or equal to 28? True or false? Well, 7 2s are 14, 4 2s are 8. Add them together. Is that greater than or equal to 28? Is 22 greater than or equal to 28? No, it's not. Oh dear. So that isn't the right side of the line then. Okay. So I thought it was going to be that nice easy triangle down there, but it isn't. If that statement is true, it means that the region we want is the region on the other side of the green line. Okay, so it's got to be below the yellow line and to the right then of the green line and above the dotted line that we've drawn. So our region R then is this region over here. Okay, so that was a little bit cheeky. Question 15. The cumulative frequency graph shows information about the marks scored by a group of 80 students in a test. Now question A says find the interquartile range. Okay, so we need to find the interquartile range of this data set from the cumulative frequency curve. We're going to do that by looking up the two quartiles, Q1 and Q3, the lower quartile and the upper quartile. Now Q1 is going to be 1/4 of the way through the data set. Now you can see from our graph that it goes up to 80. So the highest point on this graph is 80. That means that there were 80 students in the test, and actually they've told us in the question, so I should have known that already. So 80 is the number of elements. Now if the number of elements is small, you should really add 1 before you divide by 4, but if I've got 80 elements, then adding 1 isn't going to make a great deal of difference. I'm just not going to bother. So 80 divided by 4 is 20. So our Q1 is going to be the 20th value in our data set. It doesn't mean that Q1 is equal to 20. it means that if I find 20 on my cumulative frequency curve, draw along till I hit to the point where I hit the curve, and then switch directions, and then draw down, that is going to be my Q1 value. Now I read that as 52. There are 10 little divisions between 50 and 60. So I'm saying Q1 is 52. Okay? So don't be fooled in thinking you just have to divide it by 4 and that's Q1. It just tells you where to find it. 52. Right, so where's Q3 then? Q3 is 3/4 the way through your distribution. So we take our number of elements, we times it by 3, and we divide it by 4. So that is going to be the 60th value then, isn't it, on our graph. So again, we're going to take our ruler, we're going to find 60 on our graph. We're going to read across from 60 until we hit that curve. Like so, and then we're going to change directions. And we're going to read down. Okay, so I make Q3 that value down there. So again, using one little square is 1 on my graph. I reckon that is 74. Okay, so my Q3 value is 74. So Q1 is 52 and Q3 is 74, so the interquartile range then is going to be those things subtracted from each other. So 74 subtract 52, what's that? That is 22 then, isn't it? It's the distance from here up to here, that's the interquartile range. 22. Part B says the ratio of number of students passing the test compared to failing the test is 4:1. Find the minimum mark needed to pass the test. So the ratio of passing to failing is the ratio 4:1. Now if you remember, there were 80 students altogether, and if there are 4 parts for passing and 1 part for failing, 4 plus 1 is 5 parts altogether. So how much is each part worth? 80 divided by 5 then. 5s into 80 goes 16 times. That means I need to kind of scale up my ratio by a factor of 16. Okay, so 1/16, that's pretty easy, it's 16. 4 16s, double and double again, 16, 32, 64. So it's 64:16. So that means 64 students passed and 16 failed. So what must be the minimum mark needed to pass the test? Well, coming back to our graph, 16 students would have failed and the rest of them would have passed. So it's basically the bottom 16 that are going to fail, aren't they? So what we want to do is find 16 on our graph, on our cumulative frequency axes. So there are 10 divisions between 0 and 20. So 16 is going to be 2 units down then from 20, then it's going to be there. So I'm going to use my ruler then to read across from 16 and then down, and then I can find the mark which the 16th person got, and therefore I know then what they need to get in order to pass. So reading again across to the curve, that's not coming out very well, let's choose a different colour. Let's just use blue. So reading across to the curve, switching directions, about 48. So that's going to be my answer then. 48 marks. Question 16. Here is a sequence: 5, 5√3, 15, 15√3. Work out the next term and find the nth term. Okay, well, what sort of sequence is this then? You need to know about quite a few sequences for your exams. Let's just pull up a list of all the different types that you need to know about. Now the first three on this list are just types of numbers, aren't they? So the squares, the cubes, and the triangles. So you should be able to rattle those off. Then the other sorts of sequences that you need to know about: linear sequences, or arithmetic, they're sometimes called, quadratic sequences, the Fibonacci sequence, and geometric sequences. Now, which one do you think this one is? I think it is a geometric sequence. I think we are getting the next term by multiplying the previous term by a number, and that number is root 3. So if you look at the first term, I've just got 5 by itself. The next term I've got is 5 times root 3. And the next term I've got is 15. Now 15 is 5 times 3, and 3 is root 3 times root 3. So if I take 5 root 3 and multiply it by another root 3, the root 3 and the root 3 becomes 3, and 3 times 5 gives you the 15. So what we've got here is that we are getting the next term by multiplying the previous one by root 3. So 5 times root 3 is 5 root 3. 5 root 3 times root 3 is 5 times 3, which is 15. And 15 times by root 3 is 15 root 3. What we're going to get for the next term, if I multiply this by another root 3, then that's going to combine with that. So that one there, look, that root 3 and that root 3 are going to combine together to give you 3. And 15 times 3 is 45. So the next term is going to be 45. 45. Okay? And the nth term, now any geometric sequence has first term a, in this case it's 5, and when you've got a common ratio r, which in this case is root 3, then the terms I get are a, ar squared, ar cubed, and so on, and then ar to the power of 4. Okay, so the first term, so the nth term then, what's that going to be? That's going to be, so this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term, isn't it? So the nth term, what's that going to be? Well, it's going to have an a in it, isn't it? And it's going to have a power of r. Now, I don't know if you noticed that the power of r you get is 1 less than its place in the sequence. So this is the third term, and it has a power of r, which is 2. This is the fourth term. It has a power of r, which is 3. So the nth term is going to be ar to the 1 less than n, which we call n minus 1, isn't it? To the power of n minus 1. Okay, so it's a, the first term, times r, the common ratio, raised to the power of n minus 1. Okay, so what is the nth term? In this case, it's going to be 5 times root 3 raised to the power of n minus 1, 1 less than its number in the sequence. Question 17. The diagram consists of 3 mathematically similar shapes. The heights of these shapes are in the ratio of 1 to 4 to 5. Find the ratio of the total shaded area to the total unshaded area, giving your answer in its simplest form. Okay, so first off, let's just think about the relationship between length and area. Okay, when we're talking about similar shapes, if the ratio of their lengths are in the ratio of 1 to 4 to 5, then the ratio of their lengths is going to be the square of that. It's going to be 1 squared to 4 squared to 5 squared, which is 1 to 16 to 25. Okay, so that means that the area of the largest, well, it's like a cross shape, isn't it? So the big white one has an area of 25, and the little white one has an area of 1, and the grey one has an area of 16. Okay, but what we want to know is what the total shaded area to the total unshaded area is. Okay, so let's look at the shaded area first of all. The shaded area is the middle one, subtract the smallest one, isn't it? So that is going to be a ratio, well, the middle one has a ratio of 1. The kind of grey one, the shaded one, has an area of 16, and the biggest one has an area of 25. Okay, so that's kind of how it goes. So the shaded area is going to be the 16, which is inside the grey one there, less the 1 in the middle. Okay, so then the total shaded area to the unshaded area, shaded area is going to be 16 subtract 1, which I think is 15. What about unshaded area? The unshaded area is the white bit. Okay, so the outer white part is going to be the 25 subtract the 16. But then you're going to have to add on the unshaded part in the middle, which is side 1. So then the ratio of the total unshaded area, that's going to be 25 minus 16, which is 9, plus 1 is 10. So that is 15 to 10 then, isn't it? 15 to 10, can we cancel that down? They're both in the 5 times table, aren't they? So let's both divide them both by 5. So that is going to be 3 to 2. Okay, that's it. That's my answer. Given my answer in its simplest form, it is 3 to 2. Question 18a, part 1. Write x squared plus 4x minus 16 in the form x plus a all squared minus b. Okay, so this is in a quadratic expanded form. This one is in what we call the completed square form. It's fairly easy to convert one from the other. What we need to do is we take the coefficient of x here and we halve it. So the coefficient of x is 4, half of that is 2. So we're going to replace x squared plus 4x with x plus 2 all squared. Now x plus 2 all squared is x squared plus 4x plus 4. So we're actually replacing x squared plus 4x with 4 more than we should. So we need to take off a square of 2, which is 4. And then we already had minus 16 there to start with. So then we're going to group those together. So we're going to get x plus 2 all squared minus 4 minus 16 is minus 20. Okay, so that's how it goes. You start by looking at the coefficient of x. In this case, it was 4. We halve it. That's the number that appears there. You have to remember that x plus 2 all squared is not a perfect replacement for x squared plus 4x. It's 4 more than you should have. So that is why we then take off that square of 2, which is 4, and then we combine that minus 4 with the 16 to give us minus 20. Okay, so that's what we've done. Solve the equation x squared plus 4x minus 16 equals 0. Give your answer in third form as simply as possible. Okay. Now, I could go and use the formula to do this, but because I've already gone to the trouble of completing the square above, I'm going to rewrite x squared plus 4x minus 16 in the completed square form that I just found. So I'm going to replace x squared plus 4x minus 16 with its completed square form. X plus 2 all squared. That's a rubbish looking 2. Let's try that again. X plus 2 all squared minus 20, and that is equal to 0. Okay? Right, the reason I'm doing that is because I can then just solve this by rearranging rather than, extracting A, B, and C and subbing it into that really awful formula. I'm just going to rearrange this to make x a subject. So first off, I've got this minus 20 on the end. So if I add 20 to both sides, that will pop over to the other side of the equal sign then, won't it? So that's going to give me x plus 2 all squared equals 20. The next thing is to get rid of this square sign here. Now the opposite of squaring is square rooting. So if I square root both sides, the square root of x plus 2 all squared, they're opposite processes. That's just going to leave me with x plus 2 on the left. And then I need to square root this side as well, don't I? So that's going to leave me with x plus 2 all squared is equal to 20. Now actually, when you square root something like that, there's actually two possible solutions it can be. It could actually be positive root 20 or negative root 20. So it should actually be plus or minus root 20 there. The last thing I need to do here is to deal with this plus 2 over here. I just need to subtract 2 from both sides, and I have the result of kind of moving it over the equal sign. Okay, so it'll pop over there. So subtracting 2 from both sides, it's going to give me x equals negative 2, because plus 2 on one side becomes negative 2 on the other, plus or minus the root of 20. Okay, so you can see we get straight into the simplified version of the quadratic formula. So it's actually easier to do it this way than going extracting a, b, and c and subbing it in, I think. Okay, so give your answer in surd form as simply as possible. Right, let's just have a quick look at this bit on the end, root 20. Is that the simplest way we can write that surd, root 20? Now, if you think 20 has got a square factor, it's got a factor of 4, isn't it? 20 is 4 times 5. I can break up root 20 into root 4 times root 5, and the root of 4 is 2. So I can simplify that down a little bit and say that is the same thing as 2 root 5, okay? And that really is as simple as it gets. I can't really simplify it any further than that. Now, I suppose you could break this up into 2 distinct roots. You could say x was negative 2 plus 2 root 5, and x is equal to minus 2 subtract 2 root 5, but I don't actually think that's going to simplify it any more than it already is. I think it's quite neatly stated. Like that, I don't think I need to split it up into 2 answers. Okay, so I'm just going to leave it like that. X equals negative 2 plus or minus 2 root 5. Part B says, sketch the graph of y showing clearly the coordinates of any turning points. Right, now sketch does not mean plot. I don't have to find like a table of values and carefully plot these points. I just need to show the general shape and then kind of mark on my diagram any features like intercepts and turning points that crop up. Okay, now we already know that this is a quadratic because it was given in the form y is equal to ax squared plus bx plus c. Can't remember what it was now. What was it? Y equals x squared plus 4x minus 16, wasn't it? Okay, so we already know it's a quadratic, and we also know because this term here is positive, it's a smiley quadratic. In other words, it's a U-shaped parabola. It's going to look like that. Okay. The next thing we did was we completed the square, and we found that we could rewrite y as x plus 2 all squared minus 20, and from that we can read out the turning point. This value or this expression is at its minimum when this squared part at the front is equal to 0. Because when you square something, the least value it can possibly be is 0. Any other value, negative or positive, you square it, it's going to become bigger than that. So what value of x makes this bracket 0? It's going to be x equals minus 2. So the x coordinate of the turning point is negative 2. When x is negative 2, that first bracket will disappear. Negative 2 plus 2 is 0. 0 squared is 0. And you'll end up with y is equal to negative 20. So that is my turning point then. So this has a turning point at negative 2, negative 20. So that's that point there, isn't it? The lowest point on the curve. Okay, and we also know the roots of this equation. We went on to find that x equals minus 2 plus or minus, it was 2 root 5, wasn't it? 2 root 5 or root 20. Okay, so how big is the root of 20? Well, we know the root of 16 is 4 and the root of 25 is 5. So the root of 20 or 2 root 5 is going to be somewhere between 4 and 5. So we think that this bit here is about 4.5, something like that. Okay, so this graph is going to have roots at roundabout minus, well, negative 2 subtract 4.5 would be about minus 6.5. And negative 2 plus 4.5 would be 2.5, wouldn't it? Okay, now these are just estimates, so I can just kind of get a sense of the size of my graph that I need to draw. Okay, so I'm going to have a root somewhere down here, about minus 6.5, just trying to work it out relative to each other. So I'm going to have another root somewhere there in the positive 2.5 area. Okay, there or thereabouts. Okay, so I need to draw my parabola that it passes through those 2 points. So let's do that then. Let's draw that parabola in. So the turning point is going to be somewhere round here to the left of the axis, isn't it? And then it's going to go up like that, back through that point there. Okay, so if it's roughly parabolic, I think that's fine. You can obviously have a line of symmetry running down the middle. Okay, and then this lowest point on the curve, that is the point negative 2, negative 20. And I think we need to mark that coordinate on negative 2, negative 20. Okay, that's our turning point. Okay, and I think we also need to label these intercepts as well. Now we said this one on the left was around about minus 6.5, and that was just to really work out where on the line it is. Exactly what it is negative 2 subtract 2 root 5. So this one over here is negative 2 subtract 2 root 5. Oops. Negative 2 subtract 2 root 5. And this one on the other side is negative 2 plus 2 root 5. Okay, so I'm going to write the exact values on there. Okay, and that's my sketch. It's got the general shape of a parabola. It's a U-shaped parabola, not a frowny one. It's a smiley one. I've got the turning point marked at minus 2, minus 20. And I've got my two roots, negative 2 minus 2 root 5 and negative 2 plus 2 root 5. Okay, so I've got all the information on there. That's a good sketch. Let's move on. Just wanted to take a few seconds out to talk about my Patreon page, which you can find at patreon.com/Mr. Tompkins EdTech. On here you can gain access to exclusive content, including early access to my past paper walkthroughs. So if you like my content, definitely worth checking that out. Also, if you become a Pythagorean patron, you get a special shout out in every video. So check it out. Back to the maths. Question 19. The diagram shows a circle, center O. Points A, B, C, and D lie on the circumference of the circle. EDF is a tangent to the circle. Angle ABC is equal to 82, and angle ODC is equal to 57. Okay, I'm just checking through that. Really, all that information is already marked on the diagram. But always do just double check, because sometimes there's extra stuff up here that's not been marked, and if you don't put it on, it's going to make it pretty much impossible for you to answer the question. So just read through it carefully and just double check that everything is on the diagram. But here it is. Okay, right, next up, what do we need to do? We need to work out the value of x. Okay, well, that's pretty easy. Let's have a look at triangle ODC. Can you see triangle ODC? ODC. What sort of triangle is that? Well, if you think OD is, well, O is the center, isn't it? So it's a line going from the center to the edge. That is a radius, isn't it? That's a radius of my circle. But then so is O to C. That's also a radius of my circle. And those radiuses have got to be equal. So that line and that line must be equal in length, which means ODC is an isosceles triangle, isn't it? So that means that the angle there must also be 57. And if that angle is 57 and that angle is 57, if I add those together and take it away from x, from 180, sorry, I should get x. So my three angles, x plus 57 plus 57, must be equal to 180. So adding those two together, 57 plus 57 is 114. And taking that away from 180 then, 180 subtract 114. What does that leave me? 180 subtract 114, 80 subtract 14, 80, 70, 66, isn't it? So x then is 66. Okay, I'm going to add that to the diagram because I think we're going to go on and do some more calculating, aren't we, in this diagram. Next off, we need to work out the value of y. Now, it's not immediately clear how to proceed here, is it? But I've got an unused angle up here. I know that this one is 82, so it's probably got something to do with that. And also, did you notice that A, B, C, and D all lie on the circumference? So we've got here what is called a cyclic quadrilateral, haven't we? So A, B, C, D, and back again. That is a cyclic quadrilateral. Okay, so how does that help me? Well, I know in cyclic quadrilaterals, opposite angles add up to 180. Okay, so if that one over there is 82, then its opposite number, which would be kind of this whole angle down here, so including the 57 and that little bit in the middle there, must be 180 subtract 82. So what would that be? So that's ADC, isn't it? So angle ADC is going to be 180 minus 82, because they're opposite angles in a cyclic quadrilateral. So that makes it, what's that? 180 minus 82, that's 98. Okay. So if that's 98 all the way across there, then what is angle ADO? ADO then is going to be 98 minus 57. So that is 42? 41. So ADO must be 41, so that bit there must be 41 degrees. How does that help me? Are we there yet? Not really. I've got... Oh, okay. What else can I do? It would be handy if I knew this one here, wouldn't it? But I don't. If I knew that one, then I know that y, my 41, my 57, and that little angle down there all lie on a straight line. So what's that angle? Now, if I could only find this angle here, we'd be in business now, then, wouldn't I? Because that's the only one I don't know on that straight line. So how can I work out that angle down there? Okay, now my diagram's a little bit crowded now, but you can see that OD is a radius drawn at the point of contact with that tangent. So you should know that radius drawn at the point of contact with a tangent, those two lines are going to be at 90 degrees to each other, then, aren't they? So that angle there between OD and DF is 90 degrees. So angle ODF equals 90 degrees, and the reason for that is the angle between a radius and a tangent is 90. Okay, and if that is the case, then you can see that part of that angle is 57, so the other part of the angle, CDF, so CDF then, that little smidgen down there, in there, that is going to be 90 subtract 57 then, isn't it? Which is going to be 33. Okay? But probably we didn't need to do that, because if I know that that's a right angle, then that's 90 plus the 41. That tells me that y plus the 41 plus the 57 and the 33 that we just found, which we know adds up to 90, all those together lie on a straight line, so that must be equal to 180 degrees. And if that is the case, then y then is going to be 180 minus those three angles then, isn't it? So 57 and 33, you know, adds up to 90, plus the 41 is 131. So 180 subtract 131, what's that? That is equal to 49? 49 and 131 is 180, isn't it? So 49 degrees, and that's my y. Y is 49. Question 20, part A. Prove that 2x plus 1, 3x plus 2, plus x lots of 3x plus 5 plus 2 is a perfect square. Okay, now first off, what is a perfect square? Now a perfect square is just something that at the end of it we can write in brackets like that and square it. So if we can take what we've got here and rearrange it so it's like one bracket all squared, then we've got a perfect square. That's what we've got. So that's the plan. We're gonna try and re kind of constitute this so it's just one bracket all squared. Okay, now, and in order to do that, we've got a little bit of work to do. What we're going to have to do first off is to get rid of all the brackets, so multiply everything out, then collect all our like terms together. Hopefully that's going to give us a quadratic, which we can then refactorize, hopefully, into a perfect square. Okay, so first off, let's have a look at this first bracket here. We're going to do FOIL on, aren't we? First, outside, inside, last, or two eyebrows, a nose, and a mouth, whichever way you like to remember it. Let's multiply that out. So I've got 2x times 3x, which gives me 6x squared. I've got 2x times 2, which gives me 4x. I've got 1 times 3x, which gives me 3x, and 1 times 2, which gives me 2. Okay, so that first bit gives me that. Then we've got a single bracket, haven't we, multiplying through by x. We're going to have to multiply both of those terms by x. That's going to give me plus 3x squared, and x times 5 is 5x. Plus we've got this random 2 by itself on the end. Okay, so that's what we've got when we remove all the brackets. Now you'll notice we've got terms in x squared, there and there. We have got terms in x, there, there, and there. And we also have some constants here and here. So what we're going to do is going to collect all the like terms together, kind of group them all up. So I've got 6x squared and 3x squared. So 6 plus 3 is 9. So that's going to give me 9x squared. I've got 4x, 3x, and 5x. 4 plus 3 is 7, plus 5 is 12. So that's plus 12x. And 2 and 2 make 4, plus 4. So the x squared terms, the yellow ones, gave me 9x. All the green terms added together gave me 12x. And the blue terms added up to 4x. Right, okay, so we've got our expression kind of simplified down a little bit into just a normal quadratic. Let's see if we can now factorize this into two brackets. Okay, now because we've got a coefficient of x squared here, this number at the front has got a 9 in front of it. Look, that means I could theoretically have like 9x here and x here, or I could get 9x squared by multiplying 3x and 3x together. Now, given that we're trying to get this into a perfect square, I'm guessing we've got to go for 3x and 3x, haven't we? Okay, so 3x and 3x multiplies together to give me 9x squared at the front. So if you look at that one times that one, it's going to give me 9x squared. Now let's look at the other end, the 4. The number here and here multiplies together to give me 4. And if it's a perfect square, they're going to have to be the same number, aren't they? So what's the square root of 4? It's 2, isn't it? So I'm guessing that's 2 there and that's 2 there then. Everything is positive, plus, plus. Does that work? So 2 times 2 gives me 4. Does that give me 12x in the middle? 2 times 3x is 6x, 2 times 3x is 6x, 6x and 6x should add up to 12x in the middle, so that does work. Okay, so notice now then we have got two brackets which are exactly the same. So I can rewrite this as 3x plus 2 all squared, which is a perfect square. We did it. Now part B says, Gemma says the equation 2x plus 1 times 3x plus 2 plus x lots of 3x plus 5 plus 2 is equal to minus 12 has no solutions. Explain Gemma's reasoning. Okay, well, all this here, all this ujmaflit here, and that is the same thing as what we had up here, isn't it? It's the same expression. Okay, and we've just said, or we've just shown that can be rewritten as a perfect square. So I can rewrite that as 3x plus 2 all squared is equal to minus 12. Okay? But it's a perfect square. It's a square. Now, if you square something, it's positive or 0, isn't it? The smallest value a square can be is 0. And any other value, if you square it, negative or positive, gives you a positive answer. So you can't square something and get a negative number. It's not possible. So what I can say is, but 3x plus 2 all squared is greater than or equal to 0 for all values of x. Okay? So, therefore there are no solutions. There are no solutions. Have you seen this symbol before? That means for all values of. So for whatever the value of x is, 3x plus 2 all squared is going to be greater than or equal to 0. Because when you square something, it becomes positive, unless of course the thing you're squaring is 0, in which case it becomes 0. So you either get 0 or you get a positive number. In either case, it's got to be greater than or equal to 0, so it cannot be negative 12. Okay? So I've written 3x plus 2 all squared is equal to negative 12, but 3x plus 2 all squared is greater than or equal to 0 for all values of x, so there are no solutions. Okay, that makes perfect sense to me. Hope it does to you. Let's move on. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.